Okay, Mrs. Carreri, and I'm trying to put a help video together for you. On ALEKs topic 1.8. 1.8 was called linear programming. This was right after we had finished 1.7. 1.7, we had learned how to graph inequalities and solve inequalities by graphing. So we would graph the inequality x greater than or equal to 4, y greater than or equal to 3, and we would rearrange this equation to get y all by itself. That would be y is less than or equal to minus 7x divided by 6 plus 88 divided by 6. And we would graph that, and we would have to shade the region in which met these conditions. Now, the other thing we did in 1.7 is we actually, 1.7, we would find the vertices, the coordinates of the vertices of those solution regions. Excuse me. So that was kind of leading up to this. Now in 1.8, we are asked to continue that process, except now we have a function here. It z equals 4x plus 3, and these are boundary conditions that we have been given for z, okay? And we've been asked to find the maximum value of this function z, and how we would solve that problem is we would then graph these inequalities, find the vertices of that solutions region, and using the coordinates for x and y for those vertices, plug it into this equation. And the challenge that people had was using this calculator that was given to us by ALEKs or their own calculator. And I would like to show you how to utilize something on the web that can make that particular ALEKs topic rather easy or more straightforward. Go to geogebra.org/graphing. And it's a graphing calculator that's free and it's online, and it's rather helpful, and it's pretty straightforward, to be honest with you. What we're going to do is we're going to enter in these three equations, but we're not going to enter in the inequalities. We're going to set them equal to each other. So instead of x greater than or equal to 4, which I can enter, but it becomes a mess. They shade it and it becomes very difficult to see. So I'm going to hit x equals 4, and it will graph a line at x equals 4. Okay, I'm going to then hit y equals 3. I am going to then, having had my piece of paper and such that I have rearranged y, that equation to get y by itself, I'm going to hit and enter y equals minus 7 divided by 6, leave it into fractions, let the program do the work for you, plus 88 divided by 6. Okay, so there we go. I have 3 equations. So I have to now evaluate my graph. So you might have to zoom in or out, and I can now zoom in and out, and I see that here's my first equation. I will then pay attention to the original inequality. So I have to be greater than or equal to this vertical line at x equals 4. I then notice that I have a horizontal line at y is equal to 3, but based on my original inequality, I have to be greater than or equal to that. So I will be at that line or above it. And then this is the equation we rearranged, and the inequality says less than or equal to that. So I will be below that. So in order to evaluate the original question, which was to find the maximum value of the function that has this solutions region, I then need to find the vertices of that solutions region. And I will use this. Okay, so we were originally in this algebra section, and I have gone to the right of it, and you'll see a tools. I've gone to tools, and I will select intersect. This can be done on your calculator, but this is a rather useful, user-friendly website. I can go and point to the intersections that are in the region I'm interested in. And notice they label them A, B, C. I go back to the algebra section, and I now have the vertices, the coordinates of the vertices of that solutions region. And I'm going to write that down. So I have 4, 10, 4, 3, 10, 3. Okay, so now I've written that down. And then I'm going to stop sharing that. I'm going to share my iPad screen and hopefully it works. I pray that you can see that. Last time I'm okay. So now I've written down those X and Y coordinates, and I need to evaluate 4x plus 3y for each one of those coordinates. So I would get 4 times 4 plus 3 times 10. So I get 16 plus 30. So that's going to give me 46. Then I get 4 times 4 plus 3 times 3. So 16 plus 9, I get a value of 25. Then I have 4 times 10 plus 3 times 3. And I get 40 plus 9, I have 49. And the question in ALEKs asks for the max value, which will be 49. Now I will go back. And I will plug in what we just found to be 49. And let's pray that I did my math correct, and I did. So I believe the challenge that people had with 1.8 in ALEKs was using a graphing calculator to find the vertices.